Alright, so welcome back again. So this is the last video that we'll do in this series of things as far as the DC circuits and diodes go. So what I did here was I just did a little bit different of a circuit configuration. So basically I moved the diode to the front of the circuit, and then I have R1 and RL in parallel with each other. So I want you guys to know something. That basically a diode and your BJTs, so your bipolar junction transistors and all that, essentially these are really just switches and relays. Once they close, they start conducting. So it's nothing more than a switch or a relay. All right, so I know most of you have already taken the motor controls class, so just wanted you to realize that, okay? All right, so let's look. So I have two different charts here set up. I have a forward bias and a reverse bias. All right, so looking at the circuit now, let's look and see if this is forward bias or reverse bias, because that's going to determine how this circuit operates. So looking at it, you'll notice that the positive is tied to the anode. Okay, so that means that this is going to be forward bias. So that means that until I reach 0.7 volts across the anode, this will not allow current flow. So that's why this is a lot like a switch. This would be the same thing as having this. So until this diode starts conducting, it's open. So can current get to these resistors before the diode closes? It can't. So this circuit configuration is a little different than the previous ones that we did. Because until this diode reaches forward bias conduction and it starts conducting, that means that no current can flow through this circuit because the diode is up front. It's like a switch. So until we close this switch, current can't get to these resistors. So until we reach 0.7 volts, we're going to say that's what we have. Okay? So at 0.2 volts, have we reached 0.7 volts across the diode? Nope. So that means the diode is going to be open. So that means in an open, especially right here at the front, remember, when I have a series configuration, an open will always read source. So that means that the diode is going to read source voltage. And since it's open and no current can flow to these resistors, that means that these are going to be zero, because no current can flow. This is like an open switch. If current can't get to these two branches, this is like a piping system, and I have a break in the pipe, okay? If the break is up here at the front, no water is getting to these two things right there, okay? If the open was somewhere out here or even right here, like in the last circuit, water will still flow, okay? So, that being said, at 0.6 volts, have we reached 0.7 yet? Nope. So that means that the diode is going to get all the source. And then VR1 and VRL are still zero. 0.9 volts now. Is 0.9 volts enough to get this diode to conducting? Yes, it is. So therefore, 0.9 volts is enough So the diode now looks like a closed switch, which is being held closed by 0.7 volts. So that means that once we reach 0.7 on this diode, it's going to hold shut, okay, hold closed. It's going to hold that 0.7 volts hostage, and then the rest of the voltage is going to drop here and here. So at 0.9 volts, the diode has enough to lock. And then what's left? 0.7, or 0.9 minus 0.7 is going to be 0.2 and 0.2. And these will have the same voltage since they're in parallel with each other. Even if they were different value resistors, that wouldn't matter because they're in parallel. So at 2 volts, diode is still locked at 0.7. Okay? Diode is still locked at 0.7. So that means that 0.7 from 2 would be 1.3 and 1.3 across the 2 resistors. At 4 volts, diode is still holding shut, 0.7, and then the rest of it is across the 2 resistors. 10 volts, diode's still holding closed at 0.7 volts. It's conducting, so that means I got 9.3 and 9.3 here. Okay? So, not too bad. A circuit like this at first, it's a little intimidating, but as long as you know your rules for diodes, forward bias and reverse bias, then you're good to go. Okay? So next circuit, I'm going to just redraw this. So what I'm going to do is I'm going to flip the diode around. Okay? So that means that the diode is in what? Positive is to the cathode, and negative is ultimately tied to the anode. So that means that it's reverse bias. It's reverse bias. So that means that we will never accomplish the 0.7 volts more positive on the anode. So therefore, this will remain an open circuit the whole time. Since it's at the front and it's not over here in one of these branches, that means that it will be this the whole time. So what does that mean? That means that current will never flow to these 2 resistors. And this is very important to know. I know you're like, why are we learning this? It's because when you get into rectification, diodes either allow current or don't allow current to flow in particular parts of the circuit. Okay? So therefore, with that being said, we have to pay attention to this stuff, because what that basically is used for is to take AC, which is constantly swapping polarities, and it can be used to block current when it tries to flow one way. So therefore, we're taking these diodes and using it to rectify AC to DC. Whether it's an actual set of diodes in it or it's a printed circuit, diodes are used in everything. Phone chargers. I mean, you plug your phone into the AC outlet, it's got to have a way of stepping it down and converting it to DC to charge your phone. So there's diodes in there. Again, it may not actually be physical diodes, but it is printed on a little circuit board, okay? So, With that being said, let's look at how this circuit will operate. So since current will never flow, and this is an open, that means that these voltages will never be. Because current will never rise. It doesn't matter how high of a voltage I get here, these will never have a voltage because current is not going to them. It's like a break up here, okay? So that means that the diode and the source voltage will keep the same voltage all the way down. So here, 0.2 volts, 0.6 volts, 0.9 volts, 2 volts, 4 volts, and 10 volts. And what's across VR1 and VRL? 0. All the way down. Okay? So, this one should be one of the easiest ones. If you ever notice a reverse bias diode at the front of the circuit before the resistors, then you'll know that the diode's going to hold that source voltage because it's open, and everything else is going to be 0 in the circuit because current is not flowing. Doesn't matter if I added a ton of resistors out through here, never going to happen. Okay? So, I hope these videos helped you guys. So let me know if you have any questions. We're looking at our first test pretty soon once I get these worksheets out there. We're looking probably middle or so of next week. So the work that I give you starting today, I'll give you 5 or so days to get it finished. So we're looking probably either a Sunday or Monday due date. And then give y'all a couple of days to study, give you a study guide, and then we're looking at the first test sometime next week. I may actually open it up starting maybe Friday or Saturday, so that gives y'all a few days to do it. Okay? So anyway, if you have any questions, please let me know. We will still be kind of lingering in the DC world. Because once we start going over Zeners and stuff like that, that's just about my stopping point for now with the DC world as far as general purpose goes. So we still got other types of diodes to go over. So we will be revisiting DC, but our next big topic is going to be biased DC and AC. Okay, so I'm going to split it up a little bit so that way we don't have too much information on the first test. So second test will be consisted of the AC world, so it's going to be more drawing outputs, and then also biasing it with DC. Okay? All right, so anyway, you guys have a great week. If you have any questions about any of this, please let me know. And I will see you guys later. Not too much longer. We got June 19th. We should start meeting in person again. Okay? So everyone have a great day.